When I first looked at the early observational logs, I assumed 3I Atlas was just another interstellar visitor, a rare but increasingly expected reminder that our solar system is not isolated. But the numbers had a way of refusing that simplicity. The more I examined them, the more I felt something was quietly out of place, as if the object itself were holding back a part of its story. The first confirmed detection came from the Atlas Survey Network, a perfectly ordinary entry in a long list of transient objects. Its brightness curve matched what you would expect from a cold, inactive interstellar body. Its trajectory at first glance looked unremarkable, a hyperbolic path, fast, steep, consistent with an object falling past the sun only once before continuing out into the dark. That should have been the end of the mystery, yet several things did not align with the usual behavior of such objects, and that is where the questions began. Normally, an interstellar comet shows irregularities as it approaches the inner system, outgassing jets, sudden brightening, small chaotic shifts in its motion. 3I. Atlas, however, followed an almost unnervingly stable path. The residuals were too clean, the uncertainties too small, and in orbital mechanics, perfection is usually the first sign that something is being missed. I ran the trajectory reconstruction multiple times, comparing the official fits with independent models produced by research teams around the world. The results shouldn't have matched as closely as they did. Interstellar objects travel through a gravitational landscape shaped by hundreds of passing stars, clouds, and disturbances. Their motions almost always carry tiny signatures of those past encounters. But this one was almost featureless, a line drawn so straight it barely looked natural. Some colleagues suggested numerical coincidence. Others proposed that the lack of perturbation traces simply meant the object had traveled through unusually empty regions of the interstellar medium. But several analysts, speaking privately and off record, admitted they felt uncomfortable with the symmetry in the data. One of them pointed out that the entry angle into our system sat suspiciously close to the ecliptic plane, an alignment that statistically should be rare. Another noted that, for an object allegedly untouched for millions of years, its velocity dispersion seemed surprisingly tight. None of these anomalies proved anything by themselves, of course. In science, unusual does not mean impossible, but taken together, they formed a pattern I could not ignore. And the more I looked, the more I wondered why certain observational windows were missing from the public datasets. The gaps were small, a few hours here, a few hours there, but they appeared exactly where early measurements should have been most informative. No explanation was provided, and no one seemed willing to discuss the matter. I kept replaying the timeline, asking myself the same quiet questions. Why did every independent solution converge so neatly? Why were some observatories reporting faint fluctuations while others recorded nothing at all? Why did several radar scans return echoes that were later removed from the archive without comment? None of this implied intent, but it left a space where intent could be imagined, a space large enough to make me uneasy. The possibility that the object's path was not entirely passive lingered at the edge of every calculation, and though I had no solid ground to stand on, I could not escape the feeling that something about 3I Atlas was too precise for chance. For now, all I can do is follow the trail the data leaves. The anomalies are real, even if the meaning behind them remains uncertain. Whether they point to an ordinary oversight or something more complex is a question I still cannot answer. What I can say is that the next set of measurements, the ones taken as 3I Atlas approached the inner system, changed the tone of the entire investigation. And once those readings came in, it became difficult to treat this object as just another visitor drifting through our neighborhood. I'll get to that soon. I kept returning to those early anomalies because the moment 3I Atlas crossed the orbit of Mars, the situation shifted from curious to undeniably strange. Until then, most of the irregularities could still be dismissed as noise, coincidence, or incomplete modeling. But the next series of measurements forced me to reconsider everything I thought I understood about interstellar objects. At first, I only noticed a subtle deviation, a tiny drift in the residual curve, almost too small to matter. Natural bodies often behave unpredictably near the inner system. Outgassing, solar heating, dust jets, all of these can cause small, chaotic pushes. But this deviation wasn't chaotic. It repeated with uncomfortable consistency, like a quiet rhythm hiding beneath the expected data. When I compared the newest trajectory fits with the older ones, the pattern sharpened. The change wasn't random. It appeared at intervals that were suspiciously regular. I checked for instrumental bias. I checked for processing errors. I even reran the reconstruction with older data sets to make sure nothing had contaminated the pipeline. Every time, the same periodic signal emerged. Some colleagues suggested solar radiation pressure, but the magnitude was too small and the cadence too regular. Others proposed thermal outgassing, yet the object wasn't warming fast enough to justify such precision. What troubled me most was the timing. The micro shifts occurred exactly at the moments when multiple observatories were pointed at 3I Atlas. Not before, not after. Precisely then, I spoke to a radar specialist who had noticed something similar in the planetary defense logs. He wouldn't go on record, but he claimed several radar echoes had arrived with timing discrepancies too narrow to be dismissed. Minutes later, those same entries disappeared from the publicly accessible archive. Whether due to routine filtering or something less routine, I cannot say, but the timing left an impression I couldn't shake. And then came the brightness anomaly. Comets brighten unevenly as they approach the sun. It's messy, impulsive, never predictable. 3I, Atlas brightened in a smooth curve, almost mathematically smooth, as if following a predicted luminosity model rather than reacting to uncontrolled surface physics. One photometric team privately admitted they had recalibrated their instruments twice, convinced the clean rise must be the result of an error. Meanwhile, several infrared observatories recorded a faint thermal excess, not large enough to imply artificial heating, but odd enough that no one wanted to publish it without stronger evidence. The signatures were intermittent, narrow, and appeared only during periods of high observational activity. A coincidence, perhaps. But when coincidences start piling into patterns, you are obligated to ask whether coincidence is still the simplest explanation. I remember one night staring at the residual plots for so long that the lines blurred into one another. There was something about the behavior, not in the magnitude of the signals, but in their discipline, their consistency, that unsettled me. It was as if the object was responding to our attention, as if it somehow registered when it was being watched. Of course, I knew how absurd that sounded. Interstellar bodies do not react to observation. They do not sense radar beams or optical sweeps. They drift, inert, unknowing. And yet the timing of the micro-corrections, the alignment with our observational windows, the suppressed variability, all of it hinted at a different possibility, one I tried not to articulate even to myself. I decided to run one final reconstruction, this time with every available dataset stitched into a continuous chain. Optical, radar, infrared, astrometric. The trajectory that emerged was not just unusual, it was too clean. It behaved as if following a fixed plan, a long-standing path requiring minimal correction, as though the object had been guided into our system rather than carried here by chance. Still, I resisted jumping to conclusions. Science demands caution, especially when a mystery tempts dramatic answers. But the next observation broke the last piece of my hesitation. As 3I Atlas approached perihelion, several instruments detected a momentary suppression of expected outgassing. It wasn't a failure. It was a pause, a strange controlled flattening of the curve. Hours later, the activity resumed, but with lower amplitude than predicted. Such behavior has no natural explanation that fits our current models. The absence was more alarming than any presence would have been. One theorist suggested dust mantling. Another proposed thermal lag. A third quietly asked whether the object might possess internal stabilizing structures. A suggestion met with silence, then nervous laughter. But even the skeptics could not ignore that the data no longer behaved like the behavior of a conventional comet. By then, my colleagues had started speaking more cautiously. Certain terms were avoided. Others were replaced with softer phrases: non-standard behavior, unknown mechanism, non-gravitational signature. Science has a way of preparing itself for uncomfortable hypotheses long before anyone is ready to voice them. What troubled me most was the growing number of unexplained data restrictions. Several observatories reported temporary access limits to raw telemetry. Some files returned 404 errors hours after being uploaded. The official explanation cited system maintenance, but the timing aligned almost perfectly with the moments of greatest anomaly. Were the gaps meaningful, or was I simply stitching coincidences into a narrative? I tried not to speculate too far, but the pattern was becoming undeniable. Something about 3I Atlas made people uneasy, not only the scientists, but perhaps those above them. What happened next ensured that any remaining doubt would not survive much longer. It began with a set of deep space radar returns that should have been impossible for an object of this classification. Echoes with a structure too crisp, too stable, too reflective. Echoes that implied surface characteristics not commonly found on natural interstellar bodies. That was the point when even the most conservative researchers began asking whether 3I Atlas might be more than what it appeared. Not conclusively, not publicly, but quietly, in the spaces between official discussions. And just as this question was forming, the object performed its most surprising motion yet, one that would shift our entire investigation into new territory. The last irregularities we observed before perihelion had already pushed the investigation into uncomfortable territory, but what happened next turned unease into something closer to quiet alarm. Looking back, the signs were subtle, almost polite in the way they announced themselves, yet once they appeared, they reshaped every assumption we had held up to that moment. I remember starting my shift expecting routine telemetry checks. Instead, I found the new radar logs sitting in the queue, flagged for review. The echoes were sharper than any natural object of comparable size should produce. Inert rock scatters radar in irregular, noisy patterns. Dust-laced comets smear the signal even more. But 3i Atlas returned a reflection that was clean and geometrically consistent, as if parts of its surface possessed unusually uniform density. At first, I assumed calibration drift. Radar facilities occasionally produce artifacts when atmospheric conditions complicate the returns. But these echoes came from three separate instruments on two continents, all with the same timing, all with the same unnerving precision. One of the technicians, normally unflappable, asked whether we had mistakenly loaded simulated data. He wasn't joking. It took a full systems audit to confirm the returns were real. Still, surface anomalies alone weren't enough to justify the theories quietly forming in the background. Plenty of unusual interstellar bodies exist, and some may carry compositions we have never encountered. What shifted the tone entirely was the next shift in the object's motion. While passing through a region of solar wind turbulence, 3i Atlas performed a correction so small it barely touched the margins of the residual curve. Yet its nature was unmistakably deliberate. Natural objects buffeted by solar wind display chaotic jitter, a messy scatter of influences. But 3i Atlas reacted in the opposite way. The turbulence passed, and the object held its course with uncanny stability, as if compensating rather than drifting. When I plotted the correction frame by frame, a pattern emerged. It wasn't the magnitude of the adjustment that mattered. It was the timing. The response aligned perfectly with the predicted onset of turbulence, not the observed one, as though whatever controlled the movement had anticipated the disturbance before it arrived. Several researchers pointed out that complex surface geometries can create pseudo-stable aerodynamic effects, but that explanation faltered when we compared the timing. The correction began seconds before the first measurable shift in the solar wind. No natural passive system predicts future conditions with that accuracy. I found myself staring at the timestamps, aware of the weight of what they suggested but refusing to say it out loud. Others were less hesitant. A few colleagues exchanged emails speculating about internal mass redistribution. One even asked if we should consider active stabilization, phrasing carefully softened to avoid triggering administrative review. Not long after this, instruments in Chile recorded faint electromagnetic fluctuations near the object. The signature was weak, almost lost in background noise, but its periodicity was striking. The pulses repeated at harmonic intervals that matched none of the known natural processes for bodies of this scale. More troubling was the alignment. The fluctuations coincided with our highest gain observation windows. A coincidence, perhaps, or perhaps not. The number of restricted files increased. Observatories reported temporary access limitations with suspiciously precise timing. Sections of telemetry disappeared, replaced with placeholders indicating internal review. Every explanation was official, and yet none addressed the underlying question: why now, and why these data sets? In the absence of answers, patterns began to feel heavier. Almost every unexplained behavior pointed toward the same quiet implication. Something about 3i Atlas was aware of its environment in a way a natural object could not be. The moment that truly crystallized this suspicion came from an analysis conducted by an independent researcher, someone with no institutional affiliation. He contacted me anonymously, sharing a finding that both intrigued and unsettled me. When he plotted the object's cumulative deviations over time, the curve formed a repeating signal buried beneath the noise. A rhythm. A structure. He suggested, cautiously respectfully, that the pattern resembled micromaneuvers used in controlled navigation systems. Not proof, but a shape that echoed intentional behavior. I didn't know how to respond. His analysis was meticulous, his tone was measured, and his conclusion, though wrapped in hypothetical language, was clear enough. If the pattern held, 3i Atlas was not merely drifting, it was guiding itself. Before I had time to explore the implications, a new dataset arrived from an observatory in Hawaii, a thermal reading, not strong enough to be called an emission, but warmer than models predicted. The heating wasn't uniform. It appeared localized, structured, as though something beneath the surface had activated briefly. This was the first moment I felt a genuine shift inside myself, the realization that the object might not simply be unfamiliar. It might be operating. The team began drafting cautious internal notes. Words like non-gravitational behavior and indications of controlled response appeared, carefully hedged, but present. Even the most conservative analysts no longer dismissed the possibility entirely. Then, on a night when the data should have remained quiet, 3i Atlas executed its most unmistakable motion yet, a tiny deceleration, too smooth to be natural, perfectly aligned with an observation sequence that had just begun. It was as if the object acknowledged our attention. What followed in the hours after that maneuver forced us to reconsider every assumption about what we were dealing with, and what might come next. The small deceleration maneuver should have been a footnote, a minor curiosity noted and eventually forgotten, but instead it became the turning point, Once 3i Atlas made that controlled adjustment, the entire investigation shifted from cautious doubt to a focused, almost silent urgency. Even the previously skeptical analysts stopped speaking in absolutes. No one said the word artificial, but the absence of the word spoke louder than any confirmation could. I kept reviewing the telemetry from that moment, replaying the slope of the velocity curve. The drop was impossibly smooth for a natural object. You could almost draw a straight line through the data points. And what troubled me most was the timing. The maneuver began moments after a coordinated high-gain observation sweep went live. Not before, not later, exactly then. Some scientists insisted we were misreading the correlation. Others quietly admitted the sequence looked like an intentional response. What no one understood, at least not yet, was what the object was responding to. To investigate further, we began cross-referencing every observational method available: optical, infrared, radar, magnetometric. That was when a second anomaly emerged. During the same window as the maneuver, several radio telescopes reported faint, extremely narrowband reflections. Not emissions, reflections. Echoes of our own signals bouncing off the surface of 3i Atlas in a strangely coherent way. Normally, radar returns scatter in a messy pattern when they hit a rough, irregular surface. But these echoes had structure. They maintained phase stability longer than any natural surface should allow. The data hinted at reflection patterns difficult to reconcile with traditional cometary materials. It was as if certain regions of the object were designed, or simply happened, to reflect with unnatural efficiency. A few researchers suggested metallic inclusions. Others mentioned crystalline structures. But we all noticed the same detail. The reflections were strongest when we aimed our instruments directly at the object's subsolar point, the region where a hypothetical sensor would have optimal visibility. No one wanted to say it aloud, but the implication hung heavily in every discussion. The object wasn't just being observed, it was observing. Around this time, a separate team analyzing the thermal data noticed something equally perplexing. The brief heating event we had previously dismissed as noise was not an isolated incident. When plotted across several nights, a pattern emerged. Small, highly localized increases in temperature, always during observation peaks, always fading as soon as the instrument switched away. Such temporal alignment was difficult to dismiss. One researcher, hesitant even to form the sentence, proposed the possibility of reactive thermal structures. The phrase was vague enough to pass administrative review, yet its meaning was unmistakable. The object's surface was behaving like a system, not a rock. By now, an unspoken tension had settled over the team. Conversations grew shorter. Certain terms were avoided entirely. Everyone sensed that the investigation was approaching a threshold, a point where the data would force a conclusion no one felt prepared to accept. The tipping point arrived when the astrometric team released a new refinement of the trajectory. For the first time, the curve showed unmistakable deviations from the predicted gravitational path. Deviations that could not be attributed to solar radiation pressure, gas jets, or modeling error. They were too smooth, too precise, too efficient. The lead analyst tried to phrase it neutrally, consistent with low-level continuous course correction. No one challenged the wording. Once that conclusion was noted, even tentatively, the questions multiplied. How long had these corrections been taking place? Had the object performed them only recently, or had they been occurring for months, hidden beneath the noise? The retrospective analysis answered that almost immediately. The pattern had been present long before we noticed it. We had simply lacked the resolution to see it. That realization was unnerving. It meant the object hadn't simply begun adjusting its trajectory during our observation campaign. It had been doing so long before we were aware of it. Perhaps for years. Perhaps longer. As we pieced together the clues, the anticipatory maneuvers, the reflective anomalies, the thermal fluctuations, the precision of the trajectory, a new hypothesis formed quietly among the team. Not spoken, not written, but understood. Whatever 3i Atlas was, it was not inert. I kept returning to the thought late at night, long after my shift ended. If the object was self-correcting, then somewhere within it something was making decisions, something was responding to the environment, or perhaps evaluating it. And if that was true, then another question followed logically, a question that none of us had dared voice, but all of us were beginning to consider. Was the object acting alone, or was it reacting to us? The answer came sooner than expected, and it did not arrive quietly. It came in the form of a sudden shift in the optical data, a change subtle enough to miss at first glance, yet profound enough to redefine the investigation entirely. The object brightened, not from the sun, not from outgassing, not from dust jets. It brightened with a profile that resembled neither thermal physics nor natural reflectivity. It brightened in a way that followed a deliberate curve, as though revealing itself intentionally. The increase lasted only minutes and then faded, leaving us with a trace, a curve too clean, too measured, too controlled. I remember staring at the plot, realizing what the data implied. If this was a natural object, the behavior made no sense. But if it was something else, a system, a mechanism, a probe, then the brightening could have been a signal, a calibration, an activation, or something far more difficult to categorize. In the hours that followed, the object performed one final action that left every member of the team in silence. It adjusted its trajectory again, this time not slightly, not subtly, but decisively, and the adjustment pointed it directly toward the inner planets. Toward us. What happened next forced us to rethink not only the object's nature, but its intent. The moment 3i Atlas shifted onto its new trajectory, a path unmistakably aligned with the inner planets, the investigation crossed a boundary from scientific curiosity into something far more sobering. Up to that point, every anomaly could be framed as an outlier, a misinterpretation, or an inconvenient coincidence. But not this one. The adjustment was too clean, too purposeful, and too precisely calculated to ignore. When the astrometric team first presented the updated model, no one spoke. The plot showed a curve descending gently toward the ecliptic plane, intersecting a corridor of space that would bring 3i Atlas into an optimal position to observe the terrestrial planets. It was not a collision course, it was a survey path, controlled, efficient, deliberate. I remember glancing around the room waiting for someone to propose a natural explanation. No one did. Even the most skeptical researchers simply stared at the model, understanding that the margin of doubt had narrowed to almost nothing. In the days that followed, our observation schedule intensified. Telescopes across the world focused on the object, collecting more data than ever before. And that was when the behavior changed again. The first sign came in the radar logs. Returns that had previously shown subtle anomalies now displayed a new kind of coherence. The reflections were no longer simply structured, they were rhythmic. The pattern resembled a slow, stable modulation, too regular to be geological. No one could identify the mechanism behind it, but the signature was unmistakably intentional. Something was changing within the object. Then came the optical anomaly. As 3 Atlas approached a region where sunlight intensity increased sharply, the expected brightening curve failed to appear. Instead, the brightness remained almost perfectly constant, as if regulated. A natural comet cannot do that. Its surface reacts impulsively, often violently, to sunlight. But 3i Atlas behaved with controlled restraint, a kind of thermal discipline we do not see in natural bodies. That was when one of the photometric analysts, normally measured to the point of stoicism, quietly asked the question everyone else had been avoiding. What if it isn't reacting to sunlight, but to us? No one answered. No one needed to. The next observation brought the most striking evidence yet. Several radio telescopes detected faint narrowband fluctuations around the hydrogen line. Not emissions in the active sense, but subtle shifts in ambient noise as though the object were tuning itself. The fluctuations repeated with harmonic precision, forming a pattern that matched none of the known astrophysical processes for an inert object. It reminded me of something waking up, testing its environment, calibrating. By this point, the internal documentation had shifted dramatically. Words like possible autonomous mechanism and non-passive behavior appeared in official notes. A special review board was convened, though no one stated explicitly what they were reviewing, and then, as the object reached the midpoint of its adjusted trajectory, something happened that removed the last remnants of doubt. 3i Atlas emitted a brief reflective flash, not a random glint, not a tumbling surface effect. The signature was too sharp, too controlled. It resembled a directed reflection, as though a portion of the surface had aligned intentionally with the incoming radar beams. The timing aligned perfectly with our strongest transmission window. When I plotted the incident and return vectors, the geometry was nearly perfect. It was a response. After that, the behavior accelerated. The micro-adjustments grew more frequent. The thermal fluctuations became more structured. The radar reflections sharpened into narrow, coherent peaks. Every dataset pointed toward the same conclusion. The object was not just adjusting its course, it was preparing for something. The final shift occurred 12 hours later. A new maneuver, larger than any before, nudged 3i Atlas into a trajectory that placed it directly along Earth's line of sight. Not to collide, not even to approach dangerously close, but to position itself where observational coverage would be maximal, as if ensuring we would see whatever came next. When the data arrived, it did not come from light or heat or motion, it came from silence. At the moment the maneuver completed, every narrowband fluctuation ceased, the micro-adjustments stopped, the thermal anomalies vanished. The radar echoes returned to standard irregular scatter. For a few minutes, 3i Atlas behaved exactly like a natural object, perfectly inert, perfectly quiet, and then without warning a faint pulse appeared on the hydrogen line. One pulse, then silence, then another pulse, slightly shorter, then another. A pattern. Mathematical, ordered, intentional. Not a message, not yet, but an announcement. A declaration of presence. I remember staring at the spectral graph, understanding the magnitude of what we had just witnessed. For months, the object's behavior had been a whisper of intention, a trail of hints left for those willing to notice. This pulse was different. This was the first unambiguous signal. Not strong, not complex, but unmistakably deliberate. From that moment, the scientific question changed. It was no longer, what is 3i Atlas? It became, what does it want? The story does not end with an answer. Not yet. Perhaps not for a long time. But the object now sits at the edge of our observational horizon, silent again, waiting, or watching. Whether it is a probe, a messenger, a sentinel, or something we lack the language to describe, one fact remains impossible to ignore. We are no longer observing 3i Atlas alone. It is observing us, and whatever comes next will depend on a decision we have not yet made, how or whether to respond.